Hello students, how are you all? I hope you are doing well. So we are at AriserTalent and we are discussing about the chapter first of our chemistry of class 12th, that is chemical reaction and equation. So what we have discussed till now, in our previous lecture we have discussed that there is a modern concept of oxidation and reduction, and in this concept we have the two categories, that is electronic concept and oxidation number concept. So what we have discussed till now, modern concept of oxidation reduction. So in modern concept of oxidation and reduction, we have two categories. We have two categories here. The first category we have electronic concept and second category we have oxidation number concept. So among both these categories we have already discussed the electronic concept of oxidation. Now we are on our second category, that is the electronic concept of reduction. So what basically is the reduction is? Reduction is the gain or loss of an electron, in any neutral atom or ion in a reaction. If there is a gain of the electron, we can also say it as a electronation. So our first topic is oxidation, and now we are dealing with our second topic, that is reduction. So in the category of the reduction, firstly I am writing about the definition of reduction, that in case of reduction there will be a gain of electron. Gain of electron means there will be the addition of electron, and we can also say it as an electronation. So what will happen in this case? There will be gain of electron or ion in an element. Second point is, this process is also known as electronation. So second point is, this is called electronation. In case of oxidation, we have defined it as a term, that is de-electronation. De-electronation means there is a removal of an electron, but in case of electronation there will be the addition of electron. So this is termed as electronation. Now there will be the addition of an atom, ion or molecule, depends upon the some sort of reactions. Now we will deal with the reactions in case of the reduction. So our first category is reduction of atom. So in case of the reduction of the atom, we have the few examples here. Our first example will be Na plus electron gives Na. Second example we have S2 minus plus 2 electrons will give sulfur. So what you can observe here, there is a addition of ion or electron in some sort of element. So we can say that this reaction will be the reduction reaction. So here is a two basic example of the category, that is reduction of atom. Now we have our second category, that is reduction of ion. So in the category of reduction of ion, we will have another example. Our first example is Mg plus 2 plus 2 electrons will give us Mg. Second example we have Cr2O7 minus 2 plus 2 electron will give us Cr4. Our third example is Pb plus 2 plus 2 electrons will give us Pb4. So these are the basic example for the reduction of ions. What we will observe here, there is a addition of electron or ion in case of a particular cations. So these sort of reactions are categorized into the category of the reduction. Now we are left with only our one category, that is reduction of molecule. So our third category is reduction of molecule. If we are considering the case of reduction of the molecule, we have only one example in this case, that is of the manganese oxide. So what will happen in case of manganese oxide? We are provided with MnO4 negative and we will get in the product side Mn plus 2. So this will be the example for reduction of a molecule. So these are the basic reactions related to the reduction of atom ion. Ion will be cation and anion, and one category we have discussed here is the reduction of molecule. So what you observed in the case of the reduction of the molecule, we have observed that positive charge or electron is added to the equation. It means charge is added, so there will be the increment of the positive charge and there will be the decrement of the negative charge. So what will happen in case of reduction? There will be a increase in negative charge, positive charge, because positive charge is being added, and there will be decrease in negative charge. So in case of the reduction, ion or electron is being added, so we can say that there will be the increment in positive charge and there will be the decrement in the negative charge. So this is all about oxidation and reduction on the basis of electronic concept, that in case of electronic concept, what will happen? There is a loss of electron in case of oxidation and there will be a gain of electron in case of reduction. So electronic concept is all over here now. Now we are coming to our next category, that is called oxidation number concept. But before, you can copy it from here. So now we have our second category, that is oxidation number concept. So our second category is oxidation number concept. So what is the oxidation number? Oxidation number is basically a charge or on a neutral atom when all the other atoms are removed from that element. So what is oxidation number? That we have been discussed in our previous class, that it is charge on ion when all other atoms are removed. when all the other atoms are removed from compound. So this will be the definition for oxidation number. It is basically a charge on the ion when all the other atoms are removed from the compound. Now we have the few rules to write the oxidation number of an element. The topic oxidation number is very important from your board point of view because it must be necessary to calculate the oxidation number for the further reactions. So we are learning about the rules for oxidation number. So our next topic is rules for calculating oxidation number. Now, our first rule for calculating the oxidation number is, if I am considering the atom or ion in a free state, it means the atom is present in the uncombined form. We can say that the oxidation number of a particular element will be 0. So our rule number 1 is, oxidation number of an atom in free or uncombined state is 0. So if there is any element present in the uncombined form, we can say that its oxidation number will going to be 0. I am taking an example over here. Suppose we have an example of N2 K Cl2 Pb. If the element is present in the uncombined form, that is they are in the free form, so their oxidation number will be considered as a 0. Now this is our rule number 1. Now we are coming to our rule number 2. What will happen in case of the oxidation state of other elements? So our second rule is, rule number 2 is, oxidation state of hydrogen is always 1. It means for the some elements, the charge they are carry on them will be equal to their oxidation number. So our rule number 2 is, in some cases, oxidation number will be charge on that ion. So again we are taking an example for it. Suppose we have aluminium plus 3. It means aluminium is having a charge of plus 3 upon it. So we can say that oxidation number of aluminium will be 3. So this is in case of aluminium. We have certain other metals in this equation also. Now we are on our rule number 3. So our rule number 3 will be, the oxidation state in case of alkali metal is plus 1. In case of alkaline earth metal, we have oxidation state plus 2. If I am considering electronegative element, for electronegative element, the element which is more electronegative will have a negative oxidation state. So our rule number 3 is, oxidation number. First category we have alkali metals. For alkali metals, the oxidation number is +1. For alkaline earth metals, oxidation number is +2. For metals, oxidation number will be positive, and for non-metals, oxidation number is negative. And our last category is non-metals. For non-metals, oxidation number will be negative. So, this is the rule number 3 for writing the oxidation number of certain elements. So, now these are the 3 rules for oxidation number concept. Now, we have many more rules, but before you can copy it from here. So, we are on our rule number 4. The rule number 4 is the oxidation state of oxygen is always -2, but oxygen will combine with hydrogen to give the peroxide, then its oxidation number will be changed only. In case of OF2, that is oxygen fluoride, fluorine being more electronegative, so its oxidation state is +2. So, our rule number 4 is oxidation state of oxygen is -2. But what will happen if it forms peroxide? The oxidation number will be 1. If it combines with fluorine to form OF2 molecule, so in OF2 molecule, oxidation number of oxygen is +2. So, this will be the scenario for the oxidation number of oxygen in the case. So, we have rule number 4 that for oxygen, the oxidation number will vary from -2 to 2. Now, we are on our rule number 5. Our rule number 5 is in neutral atom, sum of all oxidation state will be equal to 0. So, if I am considering any neutral atom, the sum of the oxidation state will be equal to 0. Now, our rule number 6. In case of ions, oxidation number will be the sum of their charges. If I am considering any ion, it may be cation or anion, the oxidation number will be the sum of the charges upon them. So, for this category, we have an example, that is SO4 -2. This is sulfate ion. If I want to calculate the oxidation number of sulfate ion, it will be the sum of the charges, that is 0 plus minus 2, and it is equal to minus 2. So for sulfate ion, the oxidation number is minus 2. So this is all about the rules of the oxidation number. This lecture is over for today. Now in our next lecture, we will calculate the oxidation number of few elements and what are the advantages and disadvantages of oxidation and reduction reaction. Thank you so much and have a nice day.